Hello and welcome to Continuous Integration using Jenkins by Edureka. This is the video series in which we are going to talk about continuous integration in detail using Jenkins. Before we get started with the first module of this series, let's take a look at a couple of other things. So let me take you through the Lake LMS before we start with the content of module 1. So this is where you log in to get your Edureka LMS, which is learning management system provided to each and every student of Edureka. And in most of the cases, the LMS looks very similar irrespective of which course you have chosen. So if you're on your LMS, your screen should look very much like what you see on the screen now, which is mine. As you can see, this is my profile through which I have logged in already. You need to click on courses, and then once you click on classroom or my classroom, it will actually take you to the list of courses which you have registered for already. And as you can see here, I have a couple of courses already registered for me showing under my LMS. If I go to the course which is continuous integration with Jenkins, the certification course for Jenkins, this is how it should look like to you as well. And as you can see here at the top, you have the clickable buttons with the numbers, and each one denotes a module here. So you have from module 1 to 10. And then at the end of the 10th module, you have a course, or rather there is a certification project which you should be completing at the end of the course. And before the first module starts, you have an installation guide which you can click. And once you do that, it will give you one PDF file. You can keep it saved somewhere. You can create a local copy. This basically takes you through the installation procedure for Jenkins. We do go through the installation procedure as part of our course as well. However, this is a very good guide which you can just follow through and which will help you copy paste all the commands, and it will be easy enough for you to have a Jenkins instance up and running. Now in this example, what we have done is we have taken an Ubuntu instance and we are installing on an Ubuntu system, as you can see here, as we are using all these apt-get commands. However, it should work absolutely well with your, let's say if you're using a CentOS or a Red Hat instance, it should work equally well. The only thing which you need to do is you just need to replace the apt-get inst command with yum commands. As you know that yum is the package repository or package management tool for CentOS or all the RPM based package management operating systems. So it takes, as you can see here, it gives you all the instructions one by one along with these screenshots, what kind of outputs you should be expecting. And once everything is done, you can just go ahead and restart your Jenkins service. So this is a detailed guide, and this should get you started right away with the Jenkins installation. So similarly, you will have all the details. So for example, when you go to module 1, you will have the presentation. For each module, you will have a presentation and some assignment to be completed, right? In module 1, it is not there because we don't have any assignments to be completed as such. It's more of a conceptual module where we have most of the theories covered. We are defining a lot of terminologies in module 1. So that's the reason we don't have any assignment. But apart from module 1, if you go through, you have module 3, 4, almost all the modules, you will find some or the other assignment. And all these assignments are actually in PDF format. So you can download them, you can keep it saved. And then, you can just, whenever you get time, just go through and complete those assignments as instructed in the guide. So once you open it, as you can see, you get all these, the course content on your left hand side. And if you click on go back, so one thing which is missing here at the moment, which you're not able to see on my screen, will be a video recording section. Once you get this course assigned to you, by then you should have a presentation, an assignment, and a video as well, which will be a recorded video for that module. Now, video length would be varying. Some videos are maybe 45 minutes, 50 minutes long. Some videos might go up to 2 hours long, depending on what is the content we are covering for that module. But irrespective of that, you will have the recorded video for all the modules and assignments for each one of them. Apart from that, you can just click on getting started to understand what exactly you should expect and the general understanding of the course which you have registered for and what is expected out of you. You have this option of keeping things in your personal library as well. So you can keep content if you want. You can upload content. You can upload a file if you want to. You can just upload a file from computer. So this is to make your work more organized if you want to do that. Apart from that, you have something called forums. You have support. Once you click on that, it will actually take you to create a ticket. So let's say if you're facing any technical issue, you can just go ahead and create a ticket on Edureka, or you can simply raise a ticket or you can send an email to support@edureka.co as well. In fact, you have this small video available as well, which you can take a look at to understand more about the LMS. And at any point in time, if you're stuck somewhere, if you're confused, or if something is not working for you, just go ahead and give a call to Edureka Tech Support, or just raise a request by sending an email to support@edureka.co. Alright, so that was about the Edureka LMS. Now let's get started with the module 1 of this video series, which is overview on continuous integration. So the objective of this video would be, once you have completed this module, you should know and you should be able to discuss what exactly is continuous integration. You should be in a position to define it, explain it to anyone. We will have a brief overview, a high-level overview of what continuous integration is all about. Then we will take a look at how exactly we are going to implement, or the different ways to implement, a CI pipeline through Jenkins. And in the process, we will have the fundamental understanding of Jenkins as a CI tool. So before we start with the continuous integration as a concept, we need to understand a couple of things beforehand. So let's take a look at them. Before we understand CI from the DevOps perspective, let's take a look at what exactly happens when DevOps is not there, or when CI is not there. So that's what we are referring to as traditional integration. As you can see here, we have 3 developers, Dev 1, Dev 2, Dev 3, and what they are doing is they are committing on a daily basis or on a very regular basis to a GitHub repository, which is one of the most popular source code management tools out there, and it is based on Git. Git is one of the most popular source code management tools, and GitHub is one of the community-driven source code management repository, which is available to you on github.com. So the major problems in traditional integration is that, first of all, it is greater time gap in integration of codes. So there is no specific time period as to when the developers are committing their code. So there is no specific guidance on that. As and when they complete their work, sometimes it is weeks, sometimes it is months. And once every commit is done, there is an integration process involved. So the code has to be integrated, and that is where the major pain point happens. So in fact, as per one of the reports, developers, when they, out of their, let's say 100% of work or 100% of hours which they are putting in, 20% goes into writing the actual code and 80% goes into fixing integration issues. Again, that is something when, if they are not using DevOps practices, if they are not using the recommended automations, and more importantly, if they're not using continuous integration tools such as Jenkins. So integrating the code was performed manually, as we have just spoken about, and it always poses greater risk or change conflicts. So as I said, 80% of the time, they are not being productive writing new codes, rather they are fixing their old codes because of the integrating issues. And of course, since there is no tool involved in automating this build process, that is where the major pain point is there. So this is how it looks like. So you have, if you're doing development with traditional integration without a modern CI tool like Jenkins, so the major pain points are, of course, infrequent commits, and you don't have a build server, first of all. And if you see here, the integration is difficult, infrequent releases, testing happens very late in the ecosystem. And of course, as a result, as a combined result of all of this, you have lots of bugs in the system. And of course, typically there are no build servers as such, and no frequent commits, as we have seen, and changes are integrated and tested manually. There is no automation involved. There is no automated test framework such as Selenium or something else is involved here. And few and infrequent releases, of course, because if you have lots of bugs and if you have infrequent commits, if your system is not stable, if your code is not stable, it cannot be released. So you have far few releases as compared to a modern CI system. And of course, testing happens very late, and there is no trust on those tests. I mean, even if your code has passed all through those tests, you still have doubts in your mind whether your code is going to be stable on the production machines or not. And more importantly, whether the change is going to succeed. There was a big cloud over change being success. It was a 50-50 thing. It could be a success, it could be a failure. It could break your system as well. And yes, lots and lots of bugs. So once again, just to summarize the problems with the traditional integration, the first one is, of course, the implementation details have changed. So by the time you go ahead and want to put your code into production, you see that the implementation details have completely changed. The instructions have gone completely haywire here. So again, do you want to rewrite the whole code? Of course, that's a real pain. And how will I escalate the project? How will you go ahead and make this project available to the end users? And is there any other way around to manage all these changes? So these were the typical questions, or still these are the typical questions being asked by the developers and IT professionals if they are not using a modern CI tool here. So how to solve the problems? There is a specific approach which you need to take. And of course, it helps you understand and mitigate the risk here. So, this is a systematic approach. And this is something which is very important for your overall DevOps ecosystem, your overall DevOps effort which you are putting in, and for CI in particular. Now, CI is one of the components within your overall big DevOps ecosystem. However, it is one of the most important components. So if CI fails, your whole DevOps operation fails. It's very important that you get it right. So the step one would be to split the entire chunk of code into segments. Now you must have heard of something called microservices approach in recent times. If you are in the IT industry, that is something which has gained huge popularity. And that is where you break down your monolithic application into microservices. So huge amount of code. Let's say if you talk about monolithic applications, you had 10,000 lines, 20,000 lines, 1 million lines of codes for a single piece of application. Now you divide that into meaningful units, each one known as a single microservice, and then you manage these microservices independently. And of course, you keep small segments of manageable code, and then you integrate the segmented code multiple times a day. That is very important aspect. This is perhaps the most important principle of CI, that you should commit your code, or your developers should commit their code multiple times in a single day. And if not multiple times, at least once a day. If they're not doing that, then you cannot achieve proper CI. And of course, the step 4 would be to adopt a continuous integration methodology to coordinate with your team. So when we say that, basically what we mean by that is that you should have proper automation in place, you should have testing framework in place, you should have a CI server such as Jenkins in place, you should have a GitHub or a Git repository which helps you integrate all your codes, and all the developers can push into a single repository from where the code has to be built by the CI server. So all these things combined or as a whole makes a proper CI ecosystem for you. Alright, so that was the comparison between all the problems we wanted to discuss, what happens or what used to happen if you don't have a CI ecosystem in place. Now let's take a look at what exactly we mean by continuous integration. So as per the definition, continuous integration is a development practice that requires developers to integrate code into a shared repository at regular basis. Now the most important component according to me in this whole definition is the last part, that integration of the code into a shared repository at regular basis. That regular is the most important part here. Because as I said, you can have a very good automation framework, you can have an excellent CI server in place, you can have the best SCM tool at your disposal. However, if your developers are not committing or not pushing their code base into the centralized source control tool, you cannot achieve proper CI. So once you have, let's say your developers are writing their code, as you can see here, so development systems are there on which your developers are writing the code, then they commit the code into a source control tool. In this case, it is the GitHub repository. Of course, there are mechanisms to auto trigger a build in a CI tool once you have committed or pushed. This is something which we are going to take a look at in later part of the videos. One of our videos will talk about how to do build triggers in Jenkins. So then the CI process initiates. Basically, it triggers a job inside Jenkins. And of course, whatever we have defined inside the CI server, all kinds of testing, building, packaging, everything, that will take place. And once everything is done, once all the tests are completed, now again, you will have only two options. You will have either a success or a failure. So based on that, it will either go through the ecosystem and it will move all the way to production machines, and there will be a report generated and sent back to the development team. Or in fact, it will be sent to the stakeholders. It can be developers, project managers, or anybody who is related and interested in that project. So this is a very good example, or this is a very good graphical depiction of how traditional integration looks like. And then once you move to continuous integration, how does it look like against the traditional integration? So as you can see here, in case of traditional integration, the gap between multiple releases is pretty high. And it is again irregular. It's not exactly very regular. Sometimes it is this high, sometimes it is very high. And again, even the time difference, it is not exactly very regular here. Sometimes it can be weeks, sometimes it can be months. And of course, because of this problem, because of this time gap and the high amount of change which has been put into that single release, there is always a relatively greater risk or change in conflicts. So there is always a chance of failure when you're deploying your code onto the production machines or any machines for that matter. So if you compare the same thing with continuous integration, as you can see here, the integration event and releases are fairly evenly distributed, and integration time gap is relatively much less. And because of the amount of change which you are pushing to the production machines, it's very less. So even the risk of losing the changes or any kind of conflict or any kind of failed changes goes down drastically, right? So you have less chances of failure if you are putting incremental changes onto your prod machines, which is the main principle behind continuous integration. So how continuous integration works, again, this is the cycle which we have seen in one of the earlier graphs. So basically how it works is that it starts with a developer writing code on a production machines, writing code on their laptops. And once they have written their code, they basically push their changes to a centralized repository, in this case GitHub, what we have here. So developer pushes the code for review to the repository, and then basically they do commit code to a repository on a very regular basis as per the CI principle. And then this version control tool is actually being monitored. So when a commit is detected, a build will be triggered automatically. So CI will pick up review request, runs verification build, and sets verified flag based on the results. So this is something which you will define in a Jenkins job. When you're creating a job, we will see how do we define multiple build steps and multiple post build steps in order to create a single job having multiple actions to perform. Once everything is done, as we have spoken, you have only two possibilities, right? It can be either a success or a failure. So if it is a success, of course, it will move forward and you will be notifying the stakeholders, testers, etc., even the developers, that everything has gone smoothly, and you will move your code, or you will perform the further steps of continuous delivery or deployment, and the code will be moving eventually to your production machines. Let's say if build failed for some reason, let's say some test has failed or something else, there is some issue, some warning with your overall test and overall Jenkins build of that job, then of course it will go back to the developers in the form of a notification, and the whole cycle will be repeated. Developers will make the changes to the job and to their code base. Developers will make changes to their code base. Once that is done, they will again commit the code to the source code repository, and then it will be again triggered and built on a CI server. This process will be repeated multiple times till the time the code passes all the tests. That is what continuous integration is all about. So this is a pictorial depiction, another example of how development with continuous integration looks like. So you have automated builds, you have automated tests, and you have automated code quality metrics. Now the good news is that we have individual modules dedicated to each of these things which we have discussed. So we have modules on builds, we have modules on tests, and then we have modules on code quality metrics. How do we achieve them? What exactly you mean by them? Conceptually, we need to understand first. And then how do you configure those things in Jenkins, and how do you achieve, and how do you then create multiple jobs which are triggered one by one in a seamless fashion, and then based on your requirements you can actually move the code from a developer's machine all the way to the prod machines. So some of the important things to understand in this diagram would be that, first of all, the developers are doing very regular commits as per the CI principle. It is going into the source code repository. From there, the builds will be triggered on the CI server, for example on Jenkins servers, and then you have regular automated releases onto the test servers, and tests happen early and very often in these scenarios. So you have continuous testing enabled for all your builds, and whatever commits and pushes have been done by the developers, which in turn results in fewer bugs in your source code. Now, one important thing to remember is that there is a misconception that continuous integration, if you're following this principle, you will get rid of bugs. Well, that's not correct. That's a completely incorrect assumption. Now, of course, if you do CI, it is not going to remove the bugs. You will still have bugs because it is human beings. It is us who is writing the codes, right? So we will still write faulty code. We will still write incorrect logics into our source code or into our code which we are writing. What CI helps you with is that it helps you understand those bugs very early in the process, and it makes this process very trivial to find and remove those bugs. And that is how you get rid of most of the bugs. And it's like chances are very less that an actual buggy code will move all the way to production machines. So now let's take a look at where does CI fit in the DevOps environment. Now, I'm assuming that all of you who are watching this video at the moment, you all are DevOps professionals or aspiring DevOps professionals, or you have some way and somewhere involvement in the overall DevOps ecosystem. So it is very important to understand how this overall DevOps process looks like, how this overall CI and CD pipeline looks like, and more importantly, where Jenkins fit into this equation. So as you can see here, once again, we have the development, and development is going the code commit. And what is happening here, that commit, build, test, staging, and then deploy. So deployment can be to dev environment, to QA environment, and even to prod environment. And once everything is done, it will eventually be moved to the production machines. And Jenkins is right at the heart of this whole ecosystem. Jenkins helps you with source code integration. Jenkins helps you with all kinds of testing mechanisms. Jenkins helps you with the deployment to various types of environments. So Jenkins is basically at the heart and at the core of this overall DevOps ecosystem. So what is the advantage of continuous integration? We understood what a continuous integration is as a concept. Now let's take a look at what exactly you gain out of it. So some of the very obvious advantages are, first of all, it is early defect detection. Now, one very important thing which I would like to bring forward is that a lot of people think that if you are practicing continuous integration, that would remove all the bugs from your system. Now, that's a misconception, that's a myth, because no matter what kind of automation you put in place, we are human beings. So we will be writing faulty codes, we will be writing logical errors, there will be faults when we are writing code because we are human beings. However, what we achieve with the help of CI is that finding those bugs, finding those issues will be dramatically easier, and we should be able to remove it in a very smooth manner. That's what we are able to achieve with the help of CI. It removes all the overhead of finding and removing a defect from your code. It brings quality assurance because less human intervention would mean less errors, and it would mean more successful completions of your project builds. Since you have things automated and you have a lot of ways to notify different stakeholders depending on different scenarios, so you have very good visibility into your projects at multiple stages of your builds. And of course, you have reduced assumptions. So actually, when you create a CI/CD pipeline with the help of Jenkins or any other such tool, you actually remove all the assumptions and you do the actual pipeline integration. So as we always say, assumptions is the mother of all goof-ups. So you should not assume anything, whether in IT or outside IT, does not make a difference. So continuing with that, let's see the benefits of continuous integration. So of course, we have increased productivity. It dramatically increases your overall productivity when you use continuous integration. It has got improved quality, as we have spoken, because we have less number of human intervention. So that would mean less human error results. And of course, reduced risk. Since you have less human intervention, once again, you have less chances of making an error. So now let's take a look at all these points in detail, one by one. So let's say take a look how exactly we get increased productivity. Now the most important thing CI does as a practice, that it enables a shorter feedback cycle when changes are made. So as we have spoken before, what happens when you write a code and when you have CI implemented, every commit creates a set of events. It triggers a set of events with the help of a CI tool, and you are able to get the feedback in the shortest possible manner. And a very efficient CI/CD pipeline would mean that you have a continuous feedback loop created for yourself. Now code is kept in a releasable state always, because whenever we talk about continuous builds, whenever we talk about CI, if a code has passed all the test cases, the end result of a CI/CD pipeline would be an actual deployment or a deployable code. Let's say if it is a Java code base, it will be a var file or a jar file. If it is a Ruby, it will be a rake file. So depending on what kind of platform you're using, you will always have a deployable code which you can directly deploy onto the production machines. It will be an artifact ready to be deployed. Code gets back into the hands of testers quickly. So let's say if something goes wrong, or let's say if further tests are supposed to be taking place, then the code base is ready for the testers to do so. So whatever changes are required or whatever actions to be performed on the code base, it happens pretty quickly. And of course, once you have automated test cases, you don't have somebody sitting on the desk for the whole day. And if you have automated test cases, that results in people getting more work for more interesting and valuable work. And what they can do is actually, once they have automated test cases written, they don't have to sit in front of the system and run those manual tests. If you are doing manual testing, it becomes a very boring job, very mundane task after a certain point in time. So you get rid of that. You get more meaningful work to do as a QA or as a deployment engineer. And of course, that results in improves morale, making it easier to retain good developers, of course, because once you have the overall efficiency in your food chain, it makes everybody happy. It results in a better job satisfaction across the board. And yes, once all these things are implemented properly, it enables more frequent releases. If your code base is being tested properly, if your stakeholders are notified properly, and if your developers are getting very closed feedback loop, they are getting feedbacks pretty quickly, and they are able to fix the bugs in a very quick and efficient manner, that would obviously result in a more frequent releases to production machines. And finally, since you have everything in place and you are doing everything so good, it of course will enable you to work on more new features and work on in a very efficient manner when it comes to user feedbacks. Now, how does it helps you in improving quality? So making it easier to find and remove defects, because frequent integration and testing identifies bugs as they are introduced. I think we spoke about this a little earlier as well, that it does not remove the bugs completely. Continuous integration as a practice does not let you remove the bugs completely. However, it makes the process of finding and removing defects extremely easy. It becomes a mundane task for you. If you find a bug, it's extremely easy to remove it as soon as it is introduced. And the second important point is that multi-platform builds help in finding problems that may arise on some, but not all versions of the supported platform. So since you have Jenkins as a CI tool, and let's say you can integrate Jenkins with Selenium, just one example for you to provide. Now, Selenium as a tool, as you know, it helps you in testing your single code base on multiple platforms and multiple browsers. So it helps you in identifying in bugs which might not be there on one platform, but it might be there on the other platform. For example, if you have a web application, it might be running absolutely fine on a Chrome browser, but it might give you a problem on a Mozilla browser, or vice versa. So those kind of problems are dramatically easier to find, once again, if you're using CI/CD as a pipeline and if you're using continuous integration as a framework. Because tools such as Jenkins and Selenium, or as a combination of these, they give you the ability to do parallel testing. So you don't have to wait for one test to complete in order to start for the new test. You can actually have hundreds of tests running parallelly at the same time, which saves you time, which makes your code more efficient. And if there is any problem, it makes much quicker to understand and remove those problems from your code base. Now, how does it help you in reducing the risk during the building of code? Of course, because it has all the answers to below questions. How does it work is, it reduces uncertainty greatly because of all the teams that know what exactly is going on. So what is working, what is not working, what are the major issues, all of these things you have the visibility as a CI tool. If you're talking about Jenkins or any other similar tool, you have the visibility onto each and every stage of your project. And that is why you have all the answers already, and that helps you in reducing any kind of risks which happen during the build stage of the code. Now let's talk about some features of continuous integration. So first of all, you do maintain a single source code repository for your project. Now, if you have multiple projects, you might have different repositories, but for a single project, ideally you should have a single repository. And within that repository, you should have different branches for different features and bug fixes, right? That's always a good practice to have different features or different bug fixes divided into different branches. You should not have everything or multiple things clubbed into a single branch. That's not a good practice at all. Then, of course, the next step would be to automate the build. So again, with the help of Jenkins, we can use Maven as a build tool, or Ant or Gradle or MSBuild or Rakefile. So depending on your platform, now again, Jenkins supports multiple types of platforms. So any platform you have, you will have the build tool for that, and you can actually go ahead and automate that process. And of course, one of the most crucial steps of achieving a continuous integration cycle would be to make the testing procedure automated and as robust as possible. So writing very good test cases is a key element of continuous integration. Then your developers should be educated to do a commit on as frequently as possible, first of all, and every commit should build on an integration machine. So it should be set up in such a way that the moment somebody commits a code or the moment somebody pushes a code to the source code repository, it should build in an automated way on a Jenkins machine or any other CI if that is the case, and it should provide you all the results after the test cases have been run successfully. And of course, you should keep all the possible measures to keep the builds as fast as possible. Now, some of the things which you need to keep in mind, we will talk about that in detail when we are configuring jobs in Jenkins, but some of the things which we talk about mostly is that you should use Jenkins build slaves to have parallel builds if possible. You should have the CI/CD pipeline in the shortest possible manner. You should not introduce unnecessary or mundane steps in between. Make it as crisp as possible. And these are some of the best practices. When you create Jenkins pipeline, there are always best practices which you can follow and which you should follow in order to make your build as fast as possible. And of course, you should test in an environment which is as close as possible to your production environment to avoid any kind of issues later on. So the closer your test environment is to your production environment, lesser are the chances of having a change failure later on when you are actually deploying your code into the production machines. And yes, you should have as much transparency as possible. As we have spoken, with the help of notification mechanism, we send the details to multiple stakeholders. So it can be testers, it can be developers, it can be project managers. At times, it can be even customers, especially if they are internal customers. They should have the visibility into each and every step of what is going on. Typically in Jenkins, what we have seen as a best practice is that even if the people who are not directly involved with the DevOps teams, what they have is, as a stakeholders, they have the visibility into the jobs. They are able to actually see the overall pipeline, what exactly are the steps involved, and what are the plugins being used, how the tests are happening. So all these things, even though the person is not going ahead and writing the test cases, the person is not actually running these builds, but still the person has the visibility into what is going on. That's actually is a good practice, because everybody can provide their own inputs into the overall process and make it as good as possible. And then of course, as the last step, you should have automated deployments. Now, when we speak about deployments in detail, we will see the difference between continuous delivery versus continuous deployment. But in general, everything should be automated end to end when we talk about continuous integration. So some of the characteristics to be continued from the last slide, that the build is completely automated, usually through the execution of a single script. So what you do in Jenkins is that you always have an option of calling a script directly from, if you have a script already pre-written for your environment, and if it is working absolutely fine, it might be possible that you want to keep that script completely unchanged or maybe partially changed, and you want to call that script. So you have an option of calling shell scripts, PowerShell scripts, or even Groovy scripts you can write in Jenkins, and you have all these possibilities in order to automate your overall CI process. Now, the second characteristics of a CI pipeline would be that no matter how triggered or how often a run happens, a build will be starting to retrieve from the source code repository. So it will always start from fresh, from scratch. It will always be it will not be the case that, let's say if you have run a single job multiple times, and since you have the source code repository already pulled and it is there in your Jenkins cache or Jenkins workspace, that does not mean that it will be taken from there. It will always be started from scratch. At least Jenkins, when it starts, it will definitely check it if there has been any change from the last commit or from the last job run. If it is there, then it will download the fresh piece of code and then it will run all the tests, because otherwise there is no point of running multiple tests if you have a stale code. So the source code repository should always be fresh. You should always start your job by running or retrieving the code fresh from the source code repository. The third point would be, unless terminated prematurely, the end product of a build is always executable code. We spoke about it earlier as well. We always talk about deployable code. So the end result of a CI/CD pipeline would always be a deployable artifact. Now, it can be a jar file or a var file or a exe package when it comes to .NET or any other such mechanism. But the important point is it will be a ready deployable artifact, irrespective of which platform or which CI tool we are talking about. Of course, if the tests have failed in between, then yes, it will go back and there will not be any executable package. There will not be any deployable artifact because the tests have failed. Then you will not get any of those things. But if everything has passed, if all the test cases have run successfully and there is no error message or there is no warning, then of course it should be a deployable artifact as an end result. And the notification of build status, it always occurs through a feedback mechanism. Again, we have seen this before. You have an option of notifying all your stakeholders as per your requirement. And as often as you want, you can actually create multiple jobs and you can stitch together a number of jobs. And at the end of each stage, you can actually notify your stakeholders if needed. So you have all these mechanisms available in any of the modern CI tools such as Jenkins, and you can do that. You can achieve that very easily. Now what we are going to do is we will try and understand the development process or the overall deployment process first without continuous integration. How does it look like? And then we will see how does it look like when we achieve or when we implement continuous integration into the same project. So the first important thing to notice would be that there are no build servers. So there is no such thing as Jenkins or any such thing when you talk about without CI. So all these processes are manual, no frequent commits by developers. Now this is a very important step to understand. Even in CI, even if you have Jenkins and automated test cases built and everything is in place for you, if your developers are not committing or pushing their code at a very frequent interval, you cannot achieve proper CI. So this is a very important step to achieve continuous integration. And as we have spoken, as a best practice or as a general guideline for continuous integration, the developers should be committing and pushing their code multiple times a day. And if not multiple times, at least once a day. Now changes are integrated and tested manually. So you are running your test cases in a manual way. Somebody is sitting on the machines and writing and running those test cases. And he or she is capturing those results manually. Then eventually the stakeholders are again notified in a manual way. So that's a very mundane task. That's a very repetitive work. And trust me, any tester you ask, that's not something which he or she likes. Initially, for learning purpose, maybe it is good for a week or a month or maybe a couple of months, but eventually people bored out of the jobs because of this thing. It's so repetitive, so mundane that nobody likes it. And of course, all of this, the initial steps, if you see, because of no build servers, no frequent commits, and all these manual steps, you have very few and very infrequent releases, which is an obvious thing, right? And because of this, testing happens late and lack of business trust. Of course, you have written a lot of code and then the testing happens. We spoke about shifting left, right? So in this case, if you don't have a proper CI, basically we are shifting right. We are delaying the testing process and we are delaying the integration process. So because of which you find the bugs pretty late, it further delays the release process, it further delays the overall testing process, and it generates a lack of business trust among the company or the stakeholders and the customers and whoever is involved with the project. And of course, it would definitely mean lots of bugs because if testing is not automated, if testing is not at a frequent interval, and if testing is with human errors, then of course bugs will be there, even when you put things into production. So this is how it looks like, pictorial representation. So development without CI. So to highlight, you have difficult integration, you have infrequent releases, you have testing happening very late. And because of all, the combined result of all of these would be lots of bugs in your code. And of course, because of infrequent commits and lots of bugs, you have a lack of trust. It's definitely going to affect your business overall. Now the same practice, if we implement continuous integration, this is how it looks like. Very neat and tidy picture here. So you have developers committing their codes on a very regular basis into the source code repository. Now the logo, the black cat logo, is from GitHub. So Git and GitHub are two of the most popular SCM tools out there. So once the developers, they push their code into the source code repository, from there you have dedicated build servers. Now this is something which we will talk in detail when we cover Jenkins later on, probably module 4 or module 5, where we talk about Jenkins build slaves. This helps you in achieving very fast builds, first of all, and you can have parallel builds if needed. You don't have to wait for one job to be completed in order for the second one to start. You can have parallel builds which will look like and which will be actually more efficient. So you have dedicated build servers, you have regular automated releases as a result, and tests, of course, they happen very early and very often. And as a result, you have very less number of bugs, and whatever bugs are introduced in the code, it can be found and it can be removed in a very easy and a smooth manner. So you have automated builds, you have automated tests, and you have automated code quality metrics. So we have different continuous integration tools. Let's take a look at them. Some of the most popular tools out there. So we have CodeShip, we have CircleCI, TeamCity, Travis CI, Bamboo, and of course Jenkins. Now, out of these, I would say, apart from Jenkins, I think Bamboo and TeamCity are the two of the most popular tools out there. However, Jenkins, beats them by a huge margin. If you look at the Google trend, and if you check the last 3, 4, 5, or 10 years of trend on Google among all the CI tools, Jenkins would be way ahead of all these tools. I mean, I would say the overall, if you see the usership of overall CI tools, Jenkins would be used by probably 70 to 80% of the people out there. And rest all will be combined into the rest of the tools, rest 20% or rest 30%. So that's the kind of user base Jenkins has got, and that is a reason. Of course, you have a lot of reasons why Jenkins is so popular, which we will take a look later on. So it is like some of the popular things are that it is open source, it is free, and it's very flexible. So we'll take a look at all those features in detail when we talk about Jenkins. So once again, if we talk about step-by-step of implementation of continuous integration, of course, it starts with developers committing their changes very regularly. As we have spoken about it before, a number of times, I cannot emphasize this step enough. If you do everything else and if you just miss this particular step, and let's say your developers are not committing their codes on a regular basis, then everything else will go for a toss, and you will not be able to achieve CI just because of this one step. So this is perhaps the most crucial step of continuous integration. So your developers are committing their change on a very regular basis. Step 2 would be continuous integration server, such as Jenkins, will poll the code repository system. And as we have spoken before, polling the code is one of the ways. We have a number of different ways how to trigger a job in an automated fashion, which we will take a look at in a very detailed way. So after that, you have this repository system, Subversion, or any other tool for any changes. So Jenkins will basically poll the repository. It can be SVN, it can be Git, or it can be any other SCM tool. So Jenkins will poll, and if any changes are there in the code base, let's say some developer has committed or something has been changed, the automated build will be triggered, which will of course comprise of a number of steps. There will be build steps, there will be multiple testing steps, and the application will run, and application will go through a set of automated tests which are already predefined, and automated test cases are already written for this application. So once that is done, the CI server releases deployable artifacts for testing and assigns a build label to the version of the code it just built. So basically this is the one which is a deployable artifact. It will have a build number or build reference number, and this one, it may or may not go to the actual production machines. That's a different issue altogether. However, it is a deployable artifact. It is a deployable code, and it can very much go to the production machines if needed. Next step would be to automated code quality and code coverage metrics. These are all, they are run along with the unit test. So this is all part of the CI/CD pipeline when we talk about. So you have multiple types of tests running, you have code coverage metrics, you have code quality suites, you have build steps, as we have spoken, through Maven or Ant or Gradle. You can have JUnit, you can have Selenium involved. So apart from that, as part of the process, you can have Docker containers being created, and then on those containers you can run all the tests, and then you can destroy the container. So this is one of the very popular approach nowadays, to use Docker containers for your QA and test purposes. So all these steps will be inside your CI pipeline as a single step. So again, whether you want to keep as a single job or whether you want to have multiple jobs based on certain conditions, that is a choice which you have to make. Jenkins provides you all the options. It all depends upon you and your project and your code base, what exactly is your requirement and how you want to achieve it. So once everything is run, whether it is test cases or code coverage or code quality, all the results are aggregated and then reported back to Jenkins. Finally, notifications are sent to developers and all the other stakeholders. Now, if let's say there was an issue found during the whole process, of course the developers will be notified, and the team which is responsible, it can be one team or it can be multiple teams. It can be a one-person team, it can be one team having multiple developers. So again, that thing of permutation combination, it can be various combinations. So eventually whoever is responsible to fix the bugs and all these issues, the person or the team will do it, and then this whole procedure will be repeated all over again, right from step 1. Now commit their changes regularly. So this whole thing will be a repetition, and this is what we call in general as a feedback loop in DevOps terminology. It starts with, it has come from Agile, but Agile does not cover all these aspects. DevOps takes the feedback loop to a whole new level. Now, some of the important points to remember when we talk about continuous integration, that fixing broken builds should be treated as a high priority for all the team members. It is, again, this is not only the CI principle, it is one of the DevOps principles. There is no blame game anymore. Any problem is everybody's problem. It's not like it's your problem, it's not my problem. It doesn't work like that. If you are still in that model, then you are not following proper DevOps. You cannot achieve proper CI. So any kind of broken builds gets the highest priority. Because if you have a broken build, that would mean that your automated test cases are not running properly, which would mean that you have a discontinuation of service for the developers. So they are able to write the code, but they are not able to test that code, which is kind of a hindrance. It's a roadblock, which has to be fixed as soon as possible. And of course, you need to have automated deployment procedure because as we have spoken, it should be automated end to end. Now, one small point which we will discuss a bit later is automated deployment versus automated delivery. This is a technical terminology. We will talk about it when we get to it. And high quality tests. So all team members should focus on contributing to high quality tests because the confidentiality of the CI process highly depends on the quality of the tests. Now, very important thing to understand is you need to have the confidence on your test cases. You should have the understanding that if your code has passed all the tests successfully, that would mean that your code is not going to fail during deployments. And that kind of confidence you will achieve only if you have very high quality test cases written. Now, some of the barriers to continuous integration, we need to understand that as well, especially as a stakeholder and especially if we are in the driving seat, that first of all, it is not easy. It's not an easy task to do. That is in fact true for overall DevOps as well. A lot of people think that, they will take certain licenses for, let's say, Jenkins and maybe Chef or Puppet and then Docker and all, and they will implement all these tools and then, it will be done in a month or it will be done in 2 months, let's say. It doesn't work like that. It takes effort and it takes time to achieve perfection, and you still have a concept of continuous improvement. There is no end. DevOps is not a destination. DevOps is a journey. You need to understand that very clearly. And of course, as a point 2, it takes a lot of effort to achieve that. First of all, and most importantly, it is a team effort. Everybody should be involved end to end. It's not a job of only developers. It's not a job of only testers. It's not a job of only project manager or operations team. It's a combined effort. Everybody has to put in their own feedback and they have to put in their own effort to make it meaningful and make it successful. And of course, mastering on tools is definitely required. You not only need to understand CI as a process, you should understand not only Jenkins, but all the underlying technologies as well. So let's say if you are automating a Java platform, a Java-based project, then you should understand not only Java, you should understand POM, you should understand Maven, you should understand how JUnit works, what kind of testings are involved, what kind of steps are involved when you are building a Java project. So everything you should understand. The more you understand, the better CI/CD pipelines you can create and the more efficient your overall DevOps procedure will be. It requires lots of expertise and infrastructure. Now, good news is that infrastructure is not that costly anymore what it used to be 10 years back, because we are no longer reliant on, let's say, our cloud team or VMware team to provide us the necessary infrastructure. We can use the self-service portals to create the infrastructure for ourselves. If we are using container technology, then we can, as I told you before, we can have a Docker plugin involved and we can use containers instead of virtual machines to achieve all the tests in a proper way. So yes, it does require a lot of expertise, but it's not costly anymore. It's actually pretty cheap nowadays to get the required infrastructure. You just need to know what do you require and how you can achieve that. And yes, the most important part, it requires a great level of automation, because each step, what we are talking about here, whether it is about plugin installation, whether it is about calling different test cases, whether it is about implementing and integrating tools such as Ansible or Docker or Selenium, all these tools actually bring in their own level of automation, and you need to understand and apprehend all these tools in a best possible manner. So I think we have spoken in detail about continuous integration. Now, it will be a logical time to now discuss about continuous deployment, because continuous deployment is a concept which actually follows continuous integration in a CI/CD pipeline. So what exactly continuous deployment is all about? First of all, it is very closely related to continuous integration, and it refers to the release into production of software that passes the automated tests. So we have spoken about continuous integration as a process where you have an automated build is triggered and then test cases are run. You have code coverage, you have code quality metrics are being checked. So of course, if it is a failure, then of course it will go back to the developers. But let's say you have all the tests passed by your code. Then you have a deployable artifact. And as we have spoken, it is typically, let's take an example of Java. So it will be a jar or a var file, which you will get as an output. So continuous deployment takes from there and it refers to all the steps involved to take that var file and put it all the way into the production machines. Now, it might require 5 steps or it might require 50 steps. That depends on the overall size and complexity of your project. But no matter how many steps you have, anything which is taking the code from your continuous integration as an output, and putting it all the way to your production machines, this whole set of events, each and every process or each and every step combined will be known as continuous deployment. So by adopting both continuous integration and continuous delivery, you not only reduce risks of catching bugs quickly, but also move rapidly to working software. So as we have spoken, the moment somebody commits a code and if everything is going perfectly fine, eventually the code will be deployed onto the production machines as a single step without any human intervention. So that is the epitome of continuous deployment, and that is something which you want to achieve or you strive to achieve when you talk about DevOps implementation in your projects. And of course, if you have these kind of releases, these will be low risk because of so many level of automations, and you can quickly adapt to business requirements and user needs. So let's say if there is some requirement changes and if there is some business change, let's say the customer says that I don't want this, I do not want A, I want B, or I don't want X, I want Y. So those kind of changes will be pretty easy to implement. You just need to make some changes in your code base and the rest of the things will be taken care automatically. It creates a better customer experience, and which is good for you and which is good for the customer as well. So let's define continuous deployment. So it is a DevOps practice where the code changes are automatically built, tested, and prepared for a release to production. So as we have spoken, it's an extension of CI, and it takes from where CI leaves your code base. So if you see in the picture, you have the similar steps as CI, but it further gives you, in this one in CI, we were talking about check-in to the source code repository, then CI server doing the build test and all kinds of code coverage sort of things, and then providing the results back to the developers or the stakeholders. Continuous deployment takes it one level ahead, and it actually puts these things into one by one into your testing environment, into your staging environment, and if everything goes well, finally into your production environment. And at any point in time, this is something which is very important. During all these steps, at any point in time, if something fails or if the results have to be passed on to the stakeholders, you have a mechanism to provide the feedback back to the stakeholders. So as you can see here, the results are being fed by the system at every stage, from the CI server, from the testing environment, from a staging environment, and finally from prod environment as well. So we have seen continuous integration, we have spoken in length about it, then we saw about what exactly continuous deployment is. Now is the time to introduce Jenkins as a tool. So what is Jenkins first of all? Now Jenkins is a lot of things, so let's define it one by one. What are the things it can do? So first of all, and at a very basic or at a very high level, it is an implementation of a CI server. It helps you implement a continuous integration pipeline for you. It's an open source project. It is cross-platform. You can use Jenkins for any kinds of platforms such as .NET or Java or Ruby or Python. Anything virtually you can think of in terms of development platform, you can actually automate those things with the help of Jenkins. Not only that, you can actually implement Jenkins on any of the underlying platforms such as Windows or Linux or Mac or Unix or Solaris. Any of these platforms, actually you can install a Jenkins server and then you can start working on it. So practically any platform where you can install and work with a Java package or a Java software, at all those places you can actually install Jenkins. It started somewhere around 2005, and first time when it was written, it was actually by a guy called Kosuke Kawakachi, who was working for Sun Microsystems. And from then it was actually later on, as you know, Sun Microsystems was overtaken by Oracle, so it became Oracle product. And initially it was known as Hudson. There's an interesting story behind it. You can check it out on Google, what exactly happened. But eventually it was from Hudson, it became Jenkins. And it is a Java-based continuous build system. So initially when it was introduced, it was primarily meant for only Java projects. But later on, with the help of a lot of developers and a very vibrant open source community and a community of developers working towards Jenkins, today you can use Jenkins for virtually anything. Anything you want to automate, you can use Jenkins. And of course, it runs on Java servlet containers. You can run with Glassfish, you can run with Tomcat. Actually, you can run it multiple ways. You can run Jenkins as a Docker container, and multiple ways to run Jenkins actually. Jenkins is supposedly based on something called pluggable architecture. So what happens is Jenkins is a bare metal software, And then on top of Jenkins, based on your requirement, you can install and uninstall any of the plugins to work with. So let's say you want to work with Git as a source code repository. So you need to install Git plugin. Let's say you want to use TFS as your source code repository. So you need to install TFS plugin. Let's say you want to use Puppet as your CM tool. So you can install Puppet plugin for that. You want to install, or you want to work with Selenium as your, let's say, testing framework. So you can go ahead and install Selenium plugin and start working for it. Similarly, let's say later on you decide that you don't want to work with Puppet, but you want to work with Chef in your overall CI/CD pipeline. So again, you just need to uninstall the Puppet plugin and install the relevant Chef plugin. It not only that, it actually supports most of the major platforms. It can be integrated with VMware. It can be integrated with any of the configuration management tools such as Chef, Puppet, Ansible, etc. You can even manage Jenkins. I mean, you can manage the cloud platforms through Jenkins. You can actually integrate those. So you can have an integration between Jenkins and AWS. You can have an integration between Jenkins and Azure or Jenkins and Google. So all these possibilities are there when you talk about Jenkins, and everything is possible because of the plugin architecture, the pluggable architecture as we call it. And it has got already more than 1,000 plugins, and every time when you go to Jenkins, you will find something or the other new plugin has been introduced by the community developers at no extra cost to you. That's the great part. And that actually makes Jenkins so popular. That is one of the primary reasons of Jenkins being so popular. And yes, Jenkins is highly flexible, highly scalable. So you can use it for very small projects to very big projects. You can use it for very small teams. Let's say you can use it even individually if you want. And you can use it for very big teams or multiple teams. You can use it with hundreds of teams together for your purpose if you need to have, and all of these can be done parallelly. We will talk about something called Jenkins build slave architecture. So you can literally run thousands of parallel builds with the help of Jenkins at the same point in time. So let's take a look at the journey of Jenkins from Hudson. So this will be a little bit of history lesson for you, what exactly happened and how exactly Jenkins came into picture. So as we have seen before, it was written by a developer called Kosuke Kawagachi, who was a Japanese guy. And he was working with Sun Microsystems when he wrote Hudson somewhere around 2004. It was late 2004 or early 2005 when he started with this project, and immediately it became very popular within the company. Everybody started using it. The first release was in 2005. Then Kosuke worked on Hudson full time in early 2008, and by then it was extremely popular. Almost everybody was using Hudson for their requirements. And yes, became the leading continuous integration solution with a market share of over 70% in 2010. And that was not only within the company, within Sun Microsystems, but outside as well. We are talking about overall global software development community here. And then it was renamed to Jenkins somewhere around 2011. And this was just to highlight the fact that it was after Sun Microsystems was taken over by Oracle. It happened when Hudson was part of Oracle. So there was a dispute, there was some issue over there. You can check it out on Google. It's an interesting story. But eventually the end result was that Hudson became Jenkins. So some of the reasons why Jenkins is so popular is, of course, first of all, it's extremely easy to use, extremely easy to set up. You can have a proper Jenkins server set up in probably less than an hour or so. Half an hour should be good enough to set up a Jenkins server once you have the machine ready for you. And of course, you can install Jenkins, as we have spoken, on multiple platforms. You can have it on a Linux machine, on a Windows, on a MacBook, anywhere you can install and run it. It's extremely easy to configure and use. The other point is there is no limit. There is no hard limit as such when it comes to number of jobs, and there is no hard limit when it comes to number of nodes which you can configure as slaves. So which practically gives Jenkins unlimited number of jobs to be run parallelly. You can have thousands of parallel jobs running at the same time on one single Jenkins master. Now, distributed builds is something which we will talk about in detail, but this basically refers to the concept of build slaves, where you have one job running on each slave, and it can be parallel, it can be running at the same time, distributed, and it can be triggered in a very seamless automated fashion. And yes, as we have spoken, it has got great extensibility. It supports multiple version control systems. It supports multiple build tools. Multiple types of customizations can be done on its UI or anywhere else at the backend as well. You can integrate virtually any of the commercially available tools from any of the DevOps tool set. So you can have any kind of SCM tool, any kind of CM tool, any kind of code metric tool, any kind of code quality review tools, any kind of notification mechanisms. Most of the cloud vendors are supported with Jenkins. You have supports for multiple ways are supported with integration with Docker. So you have n number of ways to extend Jenkins. And it just is that imagination is your limit. You can actually, and let's say there is a specific situation you come across for which you don't have a plugin available. In that situation also, it's extremely easy to write a Jenkins plugin as well. You just need to know Java and you need to have an HPI extension to write a Jenkins plugin. It's extremely easy to do with. So where does Jenkins fits in? If you see at the diagram, Jenkins helps you in integration of source code management tool. It helps you in build. It helps you in continuous testing. It helps you in configuration management. It helps you in continuous deployment, and it helps you in continuous monitoring. So if we say in other words, Jenkins helps you with end-to-end software delivery lifecycle. It starts with version control. So the moment somebody writes the first line of code, Jenkins can help you in automating those tasks. And it goes all the way from building and testing and deployment all the way to monitoring and beyond if needed. So to answer the question, where does Jenkins fits in? It fits in all the situation. It fits in end-to-end SDLC. Now, some of the examples of the companies which are using Jenkins at the moment, these should be some of the familiar names for you. So you have Capital One, you have Comcast, you have Lockheed Martin, you have Cisco, JP Morgan, AT&T. So these are some of the big names. But if I tell you, virtually every company who is doing software delivery is using Jenkins in some or the other way. The only difference would be that some companies would be using it for very small projects or maybe partially for some of the projects. And some of the companies would be using it full-time, end-to-end for all of their project needs. That's the only difference. But if you see every company on earth, everybody, any company who is actually involved in software delivery or software development will be using Jenkins in some or the other capacity. Now, this is an interesting question. What can Jenkins do? And as we have seen with the last example, that where does Jenkins fits in? Similarly to this, Jenkins can virtually do anything. And as we have seen before, anything you need to do with Jenkins, you just need to install the right plugin for that. So it can help you with generating test reports. It helps you with pushing the artifact repositories. It helps you with deploying directly to production or test environments. It helps you in notifying the stakeholders. It helps you in doing the integration for different version control systems. It helps you in integration with any of the cloud providers. So there are multiple examples and hundreds of use cases how Jenkins can help you. So if you talk about Jenkins workflow, you will feel a lot of similarities from what the discussion we had about continuous integration, because Jenkins helps you implement CI. So if you see step 1 to all the way up to 7 or 8, it basically talks about more or less the same thing which we spoke about continuous integration. So you have developers who will be writing the codes and they will be putting the code into a source code repository such as Git. And from there, it will be fed to a CI server such as Jenkins. And then from there, it will be going to the builds. So typically a Maven build or an Ant build or a Gradle build. Once that is done, there will be multiple types of tests run on the system. Then it will be verified. It will be, flagged as a verified review. And then it will be again sent back to the stakeholders as per the notification mechanism you have set up for your CI/CD pipeline. So this is very similar to what we had discussed during our initial CI discussion. So how it happens, how it takes place. It's the same thing, just only thing is it will be implemented with the help of Jenkins as a CI tool. Even in terms of functionality, you can relate a lot of things from the initial CI discussion, because as we have spoken, Jenkins helps you implement CI for your project. So if we talk about step by step, the first step would be to get the source code from repository tools such as Git, SVN, CFS, any of these tools, doesn't matter actually, as long as the plugin is installed in Jenkins. You just need to pull it. Once it is there, Jenkins helps you perform the code compilation and build the software. And again, with multiple tools, it can be Ant, Maven, Gradle, any one of them. That's absolutely fine. Jenkins supports all of them. Then it will be running a lot of internal shell scripts or Groovy scripts, depending on how you have set up the job. Once that is done, as a fourth step, it will be automatically building and automatically running the test cases which you have set up So again, the best example would be Selenium as a testing framework. So you can have multiple tests, and you can have sequential testing, or you can have parallel testing. You can have testing in such a way that if test X passes, only then you should start with test Y. Or you can have XYZ tests parallelly to run on a single code base. So again, all these things are possible in Jenkins. It gives you all the possible ways. It all depends on your requirement and how you want to run all your test cases once the build is complete. And of course, Jenkins monitors the execution of all the above tasks, and based on the results, whether, again, there are only two possibilities. It can be either a success or a failure. So if it is a failure, of course, developers will be notified. If it was a success, it will be notified to multiple stakeholders so that it is everybody understands that the next push is about to happen. And if you have set up your job in such a way that it will go all the way to production once the notification mechanism is complete. And again, you can integrate Jenkins with multiple notification mechanisms. You can do it through email. You can set up through Twitter, Jabber, Slack, HipChat, all these, whatever mechanisms you are using inside your company as a communication tool, you can actually integrate those tools with Jenkins so that the notification mechanism is used and your stakeholders are notified with the right channel. So it doesn't always have to be email. It can be done in multiple ways. Running Jenkins is again extremely easy. As we have discussed before, it is packaged as a WAR file. Since it is a WAR file, so you can drop it into whichever servlet container you prefer. You can use it as a Docker container. You can use it on multiple types of platforms. So if you see, the native supported packages exist for Windows, Ubuntu, Red Hat family, macOS, FreeBSD, OpenBSD, Solaris, Gentoo. So multiple platforms are supported. In fact, if you see the list, all the major vendors, all the major server platforms are actually supported as per the list. Alright, so that brings us to the end of this module, and by now you should be having a good understanding of what exactly we mean by continuous integration and how you can implement, what are the steps to implement good continuous integration framework at your workplace. Then what exactly we mean by Hudson and Jenkins, what exactly is the relation between the two, and we have seen basics of Jenkins. So with that, we have come to an end of the session. I hope you have enjoyed it, and see you in the next video.